So here we're given under normal operating conditions, the electric motor exerts a torque of 2.4 kilonewton meters on shaft AB. So we can write that TAB is equal to 2.4 kilonewton meter. Each shaft is solid with a diameter of 52 meters. So we know that the diameters are going to be 52 meters. And they're asking us to determine the smallest diameter of shaft BC. So it says without increasing shearing stress. So what's shearing stress? This is shearing stress, and the max is T C over J. What's J? J equals pi C4 over 2. Okay, and with these, knowing what C is for each of them, we can find tau max for each of them because we're also given the torques. So let's do this for shaft AB, shaft BC, shaft CD, and shaft DE. So T, I can probably write that a little different. TAB is 2.4, and I'll leave out the units just for saving space. And what's this for B? Torque on B is going to be TBC 1.2. TCD equals 0.8, and then TDE equals 0.4. And we know that the diameter is 52, so C then equals 52 divided by 2. 52 divided by 2, 26. Should this be millimeter? Yes. And each shaft is solid with a diameter of 52. So why are we given different ones for different BC, CD, and DE? Why are they 40 millimeters, 46, and 46? It's saying that all of them are 52, but then it's notating all of them as different. Or is this the new design? I am going to... I guess I'm going to go with what the diagram is. That's confusing. CAB 26 0.26 millimeter meter 26 e to the negative third is 0.026. Okay, that's a kilonewton. I didn't move that. So this number is going to be a bit weird, but we'll find it out. And then CBC 46 divided by 2 is 23. CCD equals 23 as well, and then CDE is going to be half of 40, which is 20. Okay, now to find JAB. I times C to the fourth over 2. Alpha w equals second up, and then it's going to be pi times C to the fourth, and we know that C is 26, so 26 to the fourth over 2. times, oh boy, let's see. Let's make that times 10 to the third in this equation here because I really don't like how big that number is, times 10 to the negative third. That's fine enough, I guess. So now I'm getting 7.17 times 10 to the negative 7 with proper units. This is like meters. Meters like something. J B C. Same exact thing except for 26 becomes 23. 4.395 times 10 to the negative 7. And same with the other ones. This one's actually going to be the same thing. J C D 4.395. And this one's going to be to the negative or to the 20. J D E equals 2.51 times 10 to the negative 7. Okay. Now that we have J, let's find tau max. Okay. That's T. It's going to be 2.4 times 10 to the negative third times 10 to the third times C 26 times 10 to the negative third over J, which is 7.17 times 10 to the negative 7. One point 23, 4.395, 4.395 times 10 to the negative 7 actually for both these. 0.8, 23, 2.51 times 10 to the negative 7, 0.4, 20. Okay, tau max. Tau max. Okay. times 10 to the negative 6. You know what that's going to be. 0, 4 e to the third, 20 e to the negative third. So it looks like the smallest tau max is dE. So hmm, 46. Hmm. So it's just the maximum value that we have to worry about. The problem I'm having is it looks like I have different answers for this and this, and I don't explain why, because these are right. And I used the same exact method for these two, so these two are wrong. How can I get half right and half wrong if I use the same thing for all of them? TCD is 0.4. I have it 0.8. That's clearly 0.8 there. This is just kind of bizarre to me. That's right. That's right. That's wrong. And technically, they don't even do this one. They don't actually even do that one. So, a bit thrown off there. In fact, they call this, but they use this one's for this one, which they call this one. So that's weird. But either way, we know the largest is 86.9. So that's the largest. And now we have to design the diameter for BC as to not exceed this. So now we have tau max equals, well, the T for that is BC 1.2. We have C, which we don't know. And we have a J of pi C, which we don't know, to the fourth over 2. Keep this, change it, flip it. Is that right? It doesn't look like pi would cancel. Keep, change, flip. It does not look like pi is going to cancel. Unless for a complex fraction it's this. Keep it. Keep this. Change this and flip it. But now does it look like 2 is going to cancel? How do things cancel in multiplication? I have 1/2. And I multiply it by 2 over 1. Do the 2's cancel? I guess they do. Because 1 over 1 is equal to the same thing as... What am I even saying, dude? What the heck's going on anymore? What? How do we get C? I'm trying to solve for just C. I'm guessing it's not that anything cancels out, it's that it's equivalent. Which that makes sense. Okay. So we can actually rewrite this because this is not actually over anything anymore. So we can actually rewrite this as one thing. So it's 1.2 C times 2 over pi C to the fourth. C to C to the fourth. This C goes away. And this is C to the third. And then this is 2 times that. So it's going to be 2.4. And all of this is equal to tau max, which is 86.9 times 10 to the 6th. Now I'm going to switch these around, so it's going to be 2.4 all over 86.9 times 10 to the 6th equals pi C cubed. Divide this side by pi. Cube root. Let's see what we get. I'm getting that C is equal to 0.00206. Multiply that by 2. Diameter is equal to 0.00412. And if we multiply that to the third, 4.127, or 4.13 millimeter.